Alright, so let's continue uh, with the sigma notation. And let's look at this example here. The problem says like this. Uh, Find the sum of the first 100 integers. Okay, we start from 1. And also, after that, trying to figure out, okay, what's the sum of the first n integers? Okay, first n integers, starting from 1. Okay. And look at the first part. We have 1 plus 2 plus 3 plus 4, up to 100. This example, I believe I talked about in our class, right? Um, there's a great mathematician, Gauss, obviously, he is, I would say he's the top 3 great mathematicians all the time, okay? And, there's a story about Gauss when he was in kindergarten, and then a lot of naughty boys, and then the teacher trying to right, make the class silent, and then he said, "Hey, I'm gonna give you a question. If you're starting to add 1 and then add 2, add 3, up to 100, what are you gonna get, right? For the kindergarten." And the teacher was planning to take a rest, but our genius Gauss immediately said it's 5050, and then the teacher was shocked, and then couldn't believe such a kid can get the answer immediately. Then he asked Gauss, "Hey, how do you do that, right?" So then Gauss says, like in this way, which is very genius. Okay, so let's look at this, guys. 1 plus 2 plus 3 plus 4, plus 100, right? So write in that increasing order, right? Now let's write it into a decreasing order. 100 plus 99 plus 98 plus 97 plus 1. You see, guys, if I write into this, and you see, if you look at it clearly here, guys, do you realize that you have 1 plus 100, it gives you 101, right? And then if you have 2 plus 99, do you see it's also give you 101? Yes? 3 plus 98, 101. 4 plus 97, 101. 100 plus 1 is 101, right? So you have 101 plus, right? You have 101 here. You have 101 here. You have 101 here. You have 101 here. Now you see that we know that we have 100, 101, right? That's kind of like a summation of the first 100 numbers twice. Do you agree? Right? So the sum of the first 100 integers starting from 1 is gonna be 101, right? Times 100 over 2. Agree? Right? And you can easily compute this, give you 5050. Okay, 50. And so this is one way to do to think about this. Also, even without thinking in this way, if we only look at our first 100 integers, you can think about also in this way, guys. If you add 1 plus 100, it gives you is 1 over 1, right? And if you add 2 plus 99, it gives you is 1 over 1, right? 3 plus 98 give you 1 over 1. And you can think about this. You actually gonna have 50 pairs, right? 50 pairs. And then the summation of each pair is 1 over 1. So it's 50 times 1 over 1. It also can give you 50, 50. Okay, so that's the way to do the interpretation. All right. And, so right now, let me try to give you the general solution for the summation of the first n integers, okay? Right now, n, it can be any number. It can be 100, it can be 1,000, or any n. So this is how we write this. Summation k from 1 to n, right? Well, here is k. This is the sigma notation for our sum of the first n integers. And how do we calculate that? Well, do you still remember the ideas? Right? So it's the sum of the first and last one, which is n plus 1. And how many pairs of this summation I have? It's n over 2, right? Before it was 100 divided by 250. Right now it becomes n over 2. And then, so this is one of the formulas, okay? And guys, you got to know this, we're gonna have some problems based on this result. So the sum of the first n integers starting from 1, which is n plus 1 times n over 2. Where is from? I just describe. Okay. So now there are 2 more formulas. Okay. So this is the summation of the first n squares starting from 1. So in other words, you have 1 square plus 2 square plus 3 square plus 4 square plus 5 square up to n square. And this summation, it also has a formula to describe, which is n times n plus 1 times 2n plus 1 over 6. Okay, so this is the sum of squares, summation of squares. And we also have another formula, is called the summation of cubes. Okay, if you have 1 cube plus 2 cube plus 3 cube plus 4 cube up to n cube, well, this solution actually is, I will see the result is a little bit surprising. Why? Because remember, we have the sum of the first n integers is n times n over 1 over 2, right? Well, n times n plus 1 over 2. But the sum of cubes, which is that result, then square. Okay, so so those are the 2 formulas here. So right now, last part, let's go over with one problem here. The problem says like this. This is a summation, right? Sigma notation here. And then I would like to know that, okay, if I let my n goes to infinity, what is the result of this? Okay, what is the result of this? Of course, we need to do some simplification first, and then we're starting to do the limited process. Okay, let's see. Based on the properties we just introduced, okay, from 1 to n, 1 over n, right? Minus sigma notation k from 1 to n, k over n squared. And guys, this part, I would like to make it very, very clear. If we have a calculation involved with sigma notation here, n is a constant. Okay, n is a constant. For example, when n equals 100, for here it's gonna be 1 over 100, right? When n equals 1,000, this part gonna become 1 over 1,000. Do you see that? The variable during this sigma notation is k. Okay, so be very, very careful. N is a constant, k is the variable. Okay, because k is keep changing. N is You assign done. Okay. So when we try to simplify this, you can see that, guys, this is a summation of n of 1 over n together. In other words, guys, think about it this way. So that this actually is a constant here. So you will see that the summation of the first part is going to be n times n over 1. And if you do that, do you see that a equals 1? Okay, equals 1. So some of you might get confused. I would say, guys, go ahead try different numbers of n. Okay, for example, if you see k equals 1, I don't know, up to, let's see, up to 3. Let's see, 1 over 3. Do you realize that you have 1 over 3 plus 1 over 3 plus 1 over 3? Do you see it's give you 1? You can change your n to any number, but the sum will always be 1. Okay, so we got that part. Now, let's handle the second piece. Minus 1 over n squared, sigma k from 1 to n. K, okay? Again, guys, you can never pull the k out because k is a variable, it's not constant. Okay, and we have 1 over n squared here. Now, do you see that this is the sum of the first n integers starting from 1? And we just introduce the formula, right? So if we replace the formula here, you're going to have 1 over n squared times n plus 1 over 2. Okay, over 2. Okay, so we can simplify this part a little bit. It gives us is 1 minus, let's see. So it's 1 over n squared times n squared plus n over 2. Okay, over 2. And if we put everything here, we're going to have n squared plus n over 2n squared. Okay, over 2n squared. And now, after all this simplification, I want to know that, okay, if limit as n goes to infinity, what's the result going to be? So, as n goes to infinity, guys, 1 minus n squared plus n over 2n squared. I'm pretty sure everybody can handle this, right? Because this part is just a 1 constant minus limit n goes to infinity, n squared plus n over 2n squared. Do you see that this part you can either using the information we discussed from chapter 2, you can think about the dominant term, right, which is n squared on the top, 2n squared on the bottom, you got is 1 over 2. Also, you can think about it using the L'Hopital rule, because this is infinity over infinity, the indeterminate form, right? And then you can evaluate, no matter which way, it's going to be 1 minus 1 over 2. So finish the problem. Okay, so this is everything I want to talk about in 5.2. So I'll stop here.